Hello, welcome back. So we are finally getting some results now, and I'm going to share that with you quickly. So we run four separate tests, right? Yeah, four separate tests. Okay, so let me explain what we're doing. We have two data sets, HotPotQA and Music, right? Now, for each data set, I am running four separate tests. Why am I running four separate tests? Well, for each data set, there are two models I'm using to ingest them. So for Hotspot QA, so this one I have finished Hotspot QA. I'm now doing music. So I'll only talk about Hotspot QA. So for Hotspot QA, first I ran the ingestion with Gemma3 4B. Then I ran the ingestion with Gemini 3 Flash Preview. So we have a folder for Gemini ingestion and we have a folder for Gemma ingestion, right? Now, for the two ingestions, I tested the retrieval, I tested the dataset with both Gemini and Gemma. So for the Gemini ingested notes, I tested the brain with both Gemma and Gemini. And then for the Gemma ingested notes, I tested the brain with both Gemma and Gemini again. So I did this because I want to find out where exactly they shine, right? Where exactly they are good. Okay, so let me explain. So we have two main processes, ingestion and retrieval, or ingestion and chat. The retrieval and the chat go together. So yeah, with the ingestion process, it is information synthesis. We are taking all the information that is being provided. The system is taking all the information that's been provided and it's trying to make sense of that information. It's trying to represent that information in a smart way, such that in case it needs to look up that information again, it can easily do so. So we have the brain of the system, which is Neo4j graph database. The model in the ingestion process, the model looks at the nodes, looks at what it is being fed, then it extracts all the key relevant information from that and puts it into the brain. All right. So the Gemini ingestion got its own information and put into the brain. And then the Gemma ingestion also got its own information and put into the brain. So looking at the two of them, which one was able to synthesize the information better, right? Now, in order for me to determine which one was able to synthesize the information better, I have to test both of them. So um, the the test process. So over here we have the Gemini ingestion. I tested it with both Gemini and Gemma, right? So for the Gemini ingestion, when I tested it with Gemini again, the result I had was exact match 62%, fuzzy match 75%, right? We are just looking at these two metrics for now. So exact match 62%, fuzzy match 75%. Okay. Then when I tested the Gemini ingested notes with Gemma, this time the results I had was exact match 40% and fuzzy match 51%, right? So even though Gemini, which is the bigger model, synthesized the information such and well we are expecting that the synthesis will be quite good because Gemini 3 Flash is very good, or it's a bigger model, it's a more intelligent model. Gemma still struggled to work with that synthesized information, right? That's the insight we can get from this. Gemini did quite well on its own information. Gemini ingested the notes, and Gemini was supposed to use the ingested notes, the information it has extracted and synthesized to answer various questions, and it was able to do well on its own ingested notes. So it's like saying, okay, so let's say I'm preparing for a test, right? I have learned for the test and then I go and write the test. Or let me see, I go to a classroom, I write my own notes based on what the lecturer says, and then I go into the test room and then I answer based on my notes. That's what Gemini did in this case. Now, let's say there's another student who didn't go to the class. but then he is given my notes. I give him my notes, the notes that I made from the class, and he reads my notes, right? And then he goes to answer the same questions on the test. That's what Gemma did in this case. So Gemini is me. I have written my own notes from the class, and then I'm going to write the test. And I scored 62% on exact match and 75% on fuzzy match. Then Gemma is another person who I gave my notes to, and then he went to answer the questions, and he scored 40% on exact match and 51% on fuzzy match. Okay, that's how I can explain this. Now, with the Gemma ingested notes in this scenario, the other person went to the lecture hall and wrote his own notes, right? That's the Gemma ingestion. The other person went to the exam hall, wrote his own notes, and then he went to answer the test. So when Gemma went to answer the test, when the other person went to answer the test based on his own notes, again, he had an exact match of 40%, and this time a fuzzy match of 50%. In the previous one, it was what? 51. So basically the same, right? Basically the same, which is interesting. And then when the other person gave me his notes, even though I didn't go for the lectures, the other person gave me his notes. I read it, I went to the exam hall and I answered the questions. And again, I scored 65% on exact match and 76% on fuzzy match. Isn't that interesting? So when Gemini ingested the notes and answered the questions based on its own ingested notes, it had 62% and 75%. When it used the ingested notes from Gemma, it had 65% and 76%. Now, when Gemini ingested the notes and Gemma went to answer the questions based on the ingested notes from Gemini, it had 40% exact match, 51% fuzzy match. And then when it used its own ingested notes as well, again, it scored 40% and 50%. So what does this tell us? This tells us that, okay, it looks like Gemma is quite good for the information synthesis, right? Because it is basically on par with Gemini. Because if you look at it, Gemini ingested the notes and when tested, it got 6275. And then when Gemma ingested the notes and Gemini tested it again, it's got 6576, which means that Gemma's ingestion process is on par with Gemini's ingestion process. Isn't that interesting? Gemma3 4B, a 4B model, is on par for the ingestion with the Gemini 3 Flash. Crazy. Okay. Now, I also have the reports here, which, well, when I make the repository public, you can go to the reports for yourself. But yeah, this is just, I guess, surface level for the people who are following along to the videos. Okay, so we are getting somewhere. Now I am testing the music, and then I'll see if the current um the current metrics hold true, right? So right now, what I am actually thinking of doing is I'm probably going to have to find a different model, a different model for the chat, for the yeah, I mean, we're using Gemma for the chat, right? So, okay, so again, I think I need to go back a bit. I said the retrieval and the chat process are similar, or they are one. What I mean by that is in order for the system to answer a question, when you ask the system a question, the system will go and retrieve all the relevant information it needs to answer that question. And then it will give it to the LLM. And then the LLM will look at the question, look at the answer, and then give you a response based on that. So it looks like we might have to get a different model to handle the chat, the actual chat portion for our local face system. right? Because like I just said, from what we are seeing here so far, it looks like Gemma's ingestion is quite good. It's just the chat aspect that is a bit lacking because again, it didn't score that high on the test. I mean, this is quite good. 50%. It's 50%. I don't know if I would say 50%. Okay, 50% is average because that's half, right? But yeah, so that's what we have so far. Ah, if anyone has any ideas on what model I could use for the chat portion, kindly let me know. I I might try DeepSeek R1 again because DeepSeek R1 was failing on the ingestion process, right? But maybe it might do well on the chat process because in actual fact, for the chat process, the model has to think, it has to reason through the information, right? You give it a model a question, you give it all the information it needs to answer that question, and then the model is supposed to reason through everything to give you the right answer, right? Or to give you the the perfect representation of the answer that answers that question properly. Okay, so yeah, that's it. We are finally getting somewhere. So yeah, if anyone has any ideas on any models I could use for this aspect, kindly let me know. It has to be a local model. That's the number one priority. But yeah, so far so good, right? So yeah, right now as you can see over here, Republican. Who was a Republican? Hey, sorry. Okay, so right now as you can see, oh Peterson. Right now as you can see over here, we are currently ingesting the music notes using Gemma 3. So actually, hmm, what I actually want to try right now, the first thing I want to try is I'm going to use the Gemma 3 12 beam model, right? And see how that performs. If that does any better, well, that's just like a maybe like a side quest just to see how that performs because the 12B model is um a bit or significantly larger than the 4B model, and we're trying to make sure we use a reasonably small model that majority of people can use on their own machines. Okay, so that is everything for now. Thanks for tuning in. This is I mean I have instances running. So over here, this is this one here is we've ingested the music notes using Gemini here, and then we are currently ingesting the music notes using Gemma. Obviously, the Gemma process is going to be slower because it's a local model. But yeah, this is it right here. And I think with this one, we've already started writing the, yeah. Should I show the results? No, I think I'll wait in the next video. Yeah. We'll dedicate the next video to music. Okay. Thanks for tuning in. Have a good one.